Okay, this is Moser with yet another hint tip trick. This is for the Holt Physics 4A worksheet number 5, Zorba the Mastiff. So we're told that we've got this enormous dog, this 155 kilogram dog, and he is suspended in a harness from the ceiling by two cables, and the cables are at right angles to one another. So that means that they're arranged something like this. And we know that the cables are not even with one another. The angles they're making with the ceiling are not even, because we know that when we compare FT1 and FT2, we are told that one of these is twice the magnitude of the other. And I'll probably get this wrong. That's okay. For now, I'm going to go ahead and say that FT1 equals 2 times FT2. And that's just sort of one of those handy things. We're going to need that, trust me. But we can't do anything with it right at the moment. So I'm going to go ahead and put my little square representing Zorba the Mastiff in there. And this starts my free body diagram. So now I need to label other forces here. Now this is one of those where the x-axis will come in handy for finding the angles. That's where the secret to the angles lies. But for right now, I'm just going to go ahead and finish the free body diagram by breaking out those forces of tension. Okay, so I've shown the breakdown on the vectors making up each force of tension. Now I'm going to go ahead and start, well, I'm going to start with a couple basic statements. First being that the sum of forces on the x-axis is equal to 0 because this dog is not moving right to left laterally or up and down, so our sum of forces on each axis will be 0. But let's go ahead and identify the forces to the right and the left so that we can write an expression, and then we're going to park it. We'll go away from it for a second. So it's the forces to the right minus the forces to the left, and if we want to get a little bit more specific, I know that force of tension x2 minus force of tension x1 equals 0, meaning they must be equal to one another. So I've gone ahead and rearranged to show that. Now, if we look at our angles, this is where this one gets a little trickier. So if we look at our free body diagram, we're told that these cables make angles with the ceiling. So we're looking at this angle, right there. Well, if we're using that angle, then our force of tension on the x is going to use cosine to describe it. So force of tension x2 is actually force of tension 2 times cosine theta 2. And we don't know what theta 2 is. And force of tension x1 is force of tension 1 cosine theta 1. So we have those established. The one further hint I will give you at this point is that you should be carefully considering this statement here, because that would allow you to eliminate a variable. Let's go ahead and do that substitution, and then I'll leave you to fight with that a little bit on your own. So we've got it down now to ft2 cosine theta 2 equals 2 ft2 cosine theta 1, and I will just remind you to think about 90 degree triangles or right triangles, and to consider that all of the interior angles have to add up to 180. That's all I'm going to say right now. But at this point, there's enough information here that if you're really crafty, you can probably figure out the angles, the theta 1 and theta 2. And of course, you're going to need that. But in the meantime, let's go ahead and get the equation set up to deal with our force of tension on the y-axis. Okay, so I've gone ahead and specified that the sum of forces on the y-axis is equal to 0 because the mastiff is hanging suspended. And we know that the sum of forces on the y is also equal to all the forces up minus all the forces down, which means 0 equals force of tension y1 plus force of tension y2 minus force of gravity. So now let's go ahead and do our trig substitutions for FTY1 and FTY2. Okay, a little bit long, so I had to go ahead and move it down, but 0 is equal to force of tension 1 sine theta 1 plus force of tension 2 sine theta 2. This gives me a pretty good setup to move some stuff across the equal sign. Okay, so I've got force of tension 1 sine theta 1 plus force of tension 2 sine theta 2 equals mass gravity. Now, of course, I'm going to remind you about Ft1 being equal to 2 times Ft2, because that's one more place where we can eliminate a variable. So at this point, I could go ahead and factor out an Ft2. And that gives me an equation that would be pretty easy to solve from my force of tension 2. If only I knew what the angles were. So, if you can get to this point on your own, I'm going to challenge you to play around with the equation on the x-axis and try to come up with those angles. Let me give you one more hint. This is pretty elementary, very basic trig. If we look at any right triangle, we know that for theta 2 in this example, b over c is sine and a over c is cosine. And for the other angle, those are reversed. The important thing to remember is that theta 1 plus theta 2 have to add up to 90, which means theta 2 equals 90 minus theta 1. You may want to consider that as you go back and work with the equations on the x-axis to try to find those angles. Consider it a challenge. Have fun.